This is section 2.2, part B. We're going to be talking about factoring our higher order polynomials. And there are a number of different techniques we'll want to look at. One thing to keep in mind, no matter what kind of polynomial you're working with, always remember to check for a GCF before doing anything else. All right, so here we go. Following techniques for factoring polynomials with degrees larger than 2. First of all, grouping. Grouping specifically is useful when we have 4 terms in our polynomial. What we do is we take these 4-term polynomials and we just group the terms in pairs. You're familiar with this because we've used this as part of a process for factoring certain trinomials in the past. In the first group, I can factor out x squared, giving me x plus 5. And in the second group, I can factor out a negative, since there's a minus between the groups, and then also a 4, which makes that x, and notice a negative divided by negative is a plus 5 again. I do have a match between the two binomials, so I can factor out that common binomial, which leaves me x squared minus 4. I've now completed the grouping step. I know this factor is completely done because it's linear. It's to the first power. This one, though, with the x squared, I want to ask myself whether I could factor it some more. And in fact, I can. This is a difference of squares. So I'm thinking x squared had to be x times x. And that negative 4 was a positive 2 times a negative 2. Notice the outers and the inners would add up to 0, which is why I didn't get a middle term on that one. These are now all linear factors, so I know I can't get any further, and that's done. Let's try one more of those. I didn't mention it on the last one, but I did take a quick scan and notice there was no GCF for the whole polynomial. This one, however, there is. I'm looking at the numbers, and I see that I could factor out a 3 and also an x to the first. So I'm going to factor that out of all 4 terms before I do anything else. That will give me 2x cubed plus x squared plus 8x plus 4. Now this 3x is just going to continue to be brought down. It's that GCF, it's part of the factored form. But within my parentheses, I'm going to make them brackets now, I'll factor by grouping. In the first group, I can factor out an x squared. That gives me 2x plus x squared divided by x squared is 1. Plus, in the second group, I can factor out 4, and that gives me a 2x, and again, 4 divided by 4, there is 1, so plus 1. This 2x plus 1 is a common binomial, so I'll factor that out, and that leaves me x squared plus 4. First power, those are all done. I need to look at this one. Even though that's quadratic, it has a second power. I can't go any further with this one because it's a sum of squares. And as we talked about back in the last unit, the sum of squares is not factorable. So this is going to be my final factored form. All right, our second technique for higher order polynomials is looking at polynomials that are of what we call quadratic form. Typically we'll try this when our polynomial has 3 terms. A polynomial is in quadratic form when whatever power is on the middle term, you have exactly double that power on the first term. When that happens, we can typically factor our polynomial using the same product sum techniques that we studied in Unit 1. Let's take a look at this first example. I'm going to start by noticing that I do have the correct relationship here. The power on the middle term is 3, and the power on the first term is exactly double that, 6. So this is of quadratic form. Since the leading coefficient is 1, I can break this up right away, only this time instead of x times x, I need to think of what times itself would give me x to the 6th. I'll end up putting x cubed in each of my sets of parentheses, because when I multiply those, I add the exponents, giving me x to the 6th. All right, I'm now looking for a sum of 11 and a product of 18. Thinking positive 2 and positive 9 there. So x cubed plus 2 times x cubed plus 9 will be my factored form. I should ask myself whether I can go any further, and I think the answer here is no. That's a perfect cube, but 2 is not, so that's not a sum of cubes. And the same argument here. 9 is not a perfect cube either. So I'm finished. All right, let's try another one of those. First, let's check for quadratic form. 2 doubled is 4. So quadratic form is confirmed. And this time I'm not quite as lucky. I don't have a 1 as a leading coefficient, so I'm going to have to use the slightly lengthier process. I'm looking for a sum of negative 35 and a product of negative 36, multiplying the first times the last. It's 1 and 36 with the negative on the 36. I use those numbers to break apart my middle term. So I still have the 4x to the 4th, but instead of negative 35x squared, I'm going to write plus 1x squared minus 36x squared. And then there's the minus 9. Now that I have 4 terms, I can factor by grouping. And in the first group, all I can take out is an x squared. That gives me 4x squared plus 1. With a minus between the groups, I'm going to factor out a negative in the second pair. And it looks like 9 will go into both of those. That gives me a 4x squared here. And negative divided by negative is a plus 1 there. These match. Again, they have to. If they don't, it doesn't work. So I'll factor out that common binomial, 4x squared plus 1. And then I've got x squared minus 9 left. The 4x squared plus 1 is done. These are perfect squares, but it's the sum of squares, so it's not factorable. But here I've got the difference of squares. So this I can factor. X squared is x times x, and negative 9 would be positive 3 times negative 3. So x plus 3 times x minus 3. This is now in its final factored form. All right, we have one more technique to review, and this is factoring the higher order binomials. There are actually 3 binomial forms that can be factored. One we're already familiar with, and the other 2 are going to be new to us. Our difference of squares we've seen before. U squared minus v squared is u plus v times u minus v. Just to verify that it actually works, we could multiply this out using FOIL. U times u is u squared. From the outers, I would get minus uv, And from the inners, a plus uv. And in the lasts, we'd have a minus v squared. The middle terms add up to 0, so they're gone. And we get u squared minus v squared, just as we expected. So that's definitely a correct factored form. Again, notice we just were talking about this. It only works for the difference when the squares are subtracted. It does not work when you've got a sum of squares. All right, these next two are the new ones. We're going to learn how to factor a difference of perfect cubes and also a sum of perfect cubes. These two factoring formulas will be on your formula sheet. You don't have to memorize them. Just have to be able to use them. Very much like what I did above, what I'd like to do is multiply this all out and just show that we really do get u cubed minus v cubed, just to verify that the formula works. So I'm going to start by distributing the u into these parentheses. That would give me u cubed plus u squared times v plus u times v squared. Now I'm going to distribute the negative v. That's going to give me minus v times u squared minus u times v squared and minus v cubed. I do have some terms that add up to 0. I have a positive u squared v and a negative u squared v. It's just written in the opposite order. So those two add up to 0. And these two as well, positive uv squared and negative uv squared. So all I have left is u cubed minus v cubed, which is exactly what we expected. I'm going to leave this last one for you to do. It's very much the same. Try distributing those and showing to yourself that you actually do get u cubed plus v cubed. We're going to go ahead now, though, and use these two plus the difference of squares formulas as formulas that we can accept and use to factor. We'll come back and do several examples. Well, actually, we should do several examples right now, shouldn't we? What do we got left? Yes, we can do them right now. This is our last page of notes, so why not finish it off? All right, so here we go. We've got some binomial factoring formulas, the ones we just went over. They're up there for our convenience. And let's take a look at these three examples. In A, this is the sum of perfect cubes. The x cubed here is really a giveaway that it's not squares, it's cubes. And so I'm going to be using this factoring formula. U, I have to think about what cubed gives me 8x to the third. In other words, what's the cubed root of 8x to the third? That would be 2x. V, what number cubed gives me 125? Or what's the cubed root of 125? That would be 5. And then I'm just going to plug everything into my sum of cubes formula, which says u plus v, so 2x plus 5. U squared. If I square that whole 2x, I'll get 4x squared minus u times v. Multiplying these together, that's 10x plus v squared. That would be plus 25. And that is complete. One thing I'll let you know, it's just kind of a nice little feature. If you've done these correctly, this trinomial here, although you might think, maybe I should try that with sum and product, it'll never work. This should always be a prime trinomial, so you can always leave it at this stage. All right, what about the next one? 2x to the 9th minus 98x. The first thing I notice about this one is that I've got a GCF. I can factor out a 2x. which makes that x to the 8th minus 49. X to the 8th and 49 are both perfect squares. So I'm going to use my difference of squares pattern here. X to the 8th is x to the 4th times x to the 4th. And the negative 49, I'll do that as a plus 7 and a minus 7. And that one is done as well. All right, our last one, x to the 6th minus 1. I'm going to treat this one as a difference of cubes. And since it's kind of up off the page right here, let me just write it down real quick. U cubed minus v cubed is u minus v times u squared plus uv plus v squared. All right, what are u and v? Well, let's see. The cubed root of x to the 6th would be x squared, right? If I raised that to the 3rd power, 2 times 3 would give me that 6 again. And the cubed root of 1 is just 1. So I have u minus v, x squared minus 1, u squared. X squared to the 2nd power is going to be x to the 4th, plus u times v, x squared times 1 is x squared, plus v squared, 1 squared is still 1. As promised, this will not factor anymore. However, this time, this first binomial can be factored a bit more. That's a difference of squares. X squared is x times x, and the minus 1 is a positive 1 times negative 1. And there I've got my factored form. All right, that completes the section. On the next page of your course pack, you may notice that there's a little challenge there to you to consider trying to create an expanded goodness, I can't think tonight, an expanded flowchart, that's the word I was looking for factoring quadratic polynomials, and extend that now to the higher order ones. And I would challenge you to try that out and see what you can do with that. We'll be back for the next section in the next video.